I've been testing this device for about a month now. I'm holding with me a brand new filter, but have a look at the used one after a month. Wow, look at all that mosquitoes. The amount of dust there is on the fan blade. Can you imagine that without this device, you would be breathing all those particles? I invested in a dust filter. The commercial filter that I bought was doing quite a good job. Is filtering the air from your room enough? What if you can prevent the dust from entering your room? That might make more sense to me. How well do those compare? This is only 1 month. This project started when I was feeling not quite good in my room. This is where I linked that to the area where I live. There is a road passing by and a lot of polluting industry nearby. Most houses are equipped with central ventilation system, which take out the air from the house and vent it outside. But that air that is vented out must come in. They have vent on top of each room that brings in fresh air, and it gets picked up from the kitchen and the bathroom mainly. This is my plan. I choose 2 sizes of filter. I'll use a fan to blow air through it. I'll have to try with different size of fan. But this one is a 140mm fan. Either I put 2 of it, or just simply cut the filter. Is this enough for this? Or should I even use like 1 fan and this big filter? It has less restriction on that fan because this is not made to push air through a normal filter. As for the vent, what I want to do is to replace those vents on the top. I have to make a funnel from this vent to the fan. I have some construction going outside, so I had to plug it as it was too noisy. Not something you want to do because you need ventilation in your room, otherwise you could have mold and stuff. You can now see the vent. I'm not sure if the vent will be large enough for the airflow. The fan with the actual vent. What I would want in my case is to bring air from the outside to inside, because my CO2 level is just... I have over 4000 ppm when I sleep. Measure PM 2.5. I can definitely hear it fine. Not sure you can hear it. After a lot of search, I found this sensor that I could use for the particle matters. But in the end I found something even better. Sensorion SEN55. A drawing of the window that we have. It must fit on the 3D printer plate. I want for now to see if the slit is large enough. So I came up with this. We have the fan and the bracket that I will print, and just behind it will be the slit. It will reuse the same hole, then the fan will screw on the top. This will serve a few things. Is 1 fan enough for that? If not, then would 2 fans be enough for that? In theory, the slit is not enough for the maximum airflow of the fan, but since we use a filter afterwards, maybe the filter will restrain the flow enough so it doesn't restrain the fan. I'm not sure that's clear. It does fit fine on the bed. It will take about 3 hours. Because I don't have much space, it's usually stored up there on the shelf. Careful. I really enjoy those printers. It was on the shelf just a few minutes ago. Three hours left. This part was done in 3 hours. One thing I didn't like about this fan is that there is a gap What I will do for now is apply some tape. For the final version, I will make a lip that will cover completely the fan. Oil prints over here. It's time to test. You see how close that is. I only have about 2 millimeters of wall thickness. 2 wooden screws like these. Now that's tight. That's pretty sturdy. I can definitely feel the air. It doesn't restrict that much the flow. This is how it is. With no fan, it is here. A simple 12-volt power supply. 2800 RPMs. It will be noisy. I installed it the wrong way, so it's sucking air in from that. Wait, I wanted to show you something. Look at that airflow. I think it will make a lot of difference now. Installing the fan the wrong side reminded me something. I haven't actually explained why I want the air to come in and not out. There is 2 main reasons for that. The central ventilation is pulling air from the house to the outside. If I blow air out, it will kind of work against the central ventilation for the whole house. The second reason is that pulling the air from the outside and filtering it through a HEPA filter will ensure that all the pollen and any possible things that is in the air is filtered through it. I'm not sure what grade it is. It's written HEPA, which should be good enough. Yeah, I need to check that. Weird. I think I have to make the funnel a bit larger. It might bring too much restriction to the flow. It does blow air, but not much. You can feel something, but it's not that hard compared to pushing air from that. Maybe I should install the fan outside. 35 or so. 50. Now, that's definitely not... I can't fit 50 into 35. I came up with a design that I think is pretty clever. Spacer is fine, but I don't have a long enough screw to fit through the fan and also the spacer that is about 30 millimeters.
Thanks to our sponsor for today's video, JLCMC. I ordered a variety of parts and mounting kit for my project. Everything is well packaged and properly secured. Everything is shipped through quickly and it's there in just a few days. Heads up to the link in the description. There is a $70 coupon included. They offer a variety of product, even fan and sensors. In my case, I needed a linear actuator. Using the filter on the left side and included datasheet on the website, I was able to find exactly what I needed. Add it to the cart, then secure the checkout. Add in your credential, name and address, and select your delivery option.
It is now 12 and the part is just done. To mount this, then the fan would be screwed on it. I really hope that it works, because there is no way I'm sleeping fine after failure. It does make a difference. Now I can feel the air. Before that I felt nothing. Seems like I have some vacuum in the middle. Like in the middle here I have some vacuum, and on the outer ring it blows air out. A quick update on the afternoon with the fan mounted but not turned on because I can't stand the noise. Around 2145 yesterday, and today at around that same time 1800. Here it is. I changed the quality profile so it takes a bit more time to print, and since it was done during the night, I was in no rush. And look at that quality underneath, it's much better. So in theory the fan should fit on this gap, and this will be screwed to the fan. This is the filter I'm going to use. I don't think there is a side to install it. Tiny strips to help pull it out, and also from the manual I don't see much difference, except maybe that foam. Oh, that's a tight fit. Double-sided tape, so I'm going to peel it. I add the weather strip now. Yep. The hole just large enough so I could screw it in and they stay in place while I could still turn it without blocking the thread. So if you look over here, you can see that it's kind of bulging. At least I'll be sure that there is no air leak. Overall, I have to say that it looks pretty slick. So I can feel the air moving, but since the area is much larger, I feel something like it's not as strong as initially. Right, I know you want to see with the paper, so let me do this. It does something, look. I will let that run at full speed and try my best to work for at least few hours and see how the CO2 level is changing. Mosquito, look. Just the time I take to change that filter and it already comes in. If I use the original vent, I think they fit through it, right? For the sensor, this is the wiring from the manufacturer. So instead of using that ESP32 full size, I will use this. It's an ESP32 C3. I don't mind much about the size, but it's more about not wasting resources. A few bucks cheaper. I'm back from my trip and I got some interesting package with me. I bought another brand of fan that's supposed to have more pressure. This type of fan, I'm curious to see how that would perform because it's actually a radial type fan, so they make much more noise. I think I will be able to dim them down. Inside of this package, some box that I use for fishing. This is what's going to power the project. This small 20 watt power supply. This is what I'm going to use and hopefully that works. I'm gonna try it. This is a PM sensor. This is what I'm going to use to define how polluted the air is from the multiple size of particles that they could be. The problem is that this model is quite old and in theory should last about 1 to 3 years. And I just don't want to keep buying, throwing it away each year or so. This is the connector that fits into the sensor itself, and then I will cut the cable on the other end to wire it myself. Sensorion SEN55. It is a model that is not only measuring the particle, but also the temperature, humidity, VOC and NOx. I'm not sure I will be using that, but the sensors are roughly the same size. I have a problem with those sensors. How are you supposed to mount them? Because there is no screw or anything to attach them. Even though you might not like it, they are comfy. We have now connected the board, and the one pin is for the fan control. Machine's been running the whole night, and I think I've broken it. Sounds like it's touching something inside. It has been printing the whole night, and I have this, the adapter for the slit. This is the holder for the filter. I even printed this. I have this. On top goes the gasket, then goes the fan, and then I have made this notch. In theory that was enough. Those holes over here are threaded so I could fit the screw in, but as you can see it doesn't fit properly. I need to clean the thread using this. This tool is terrible, it doesn't even hold it properly. What do you expect from a box with all of this for $10? At least I was able to make it work. So the fan should go like this. Popping by accident. Pretty good for the first design, I think. But thanks to the manufacturer, they provided the drawing for this, so I just had to make my own bracket around it. For the first design, I didn't want to waste too much plastic as I didn't know where I should mount the sensor. So what I came with was the bracket here would then fit exactly on that corner. And both holes are aligned. I would just then need to use a longer screw. It would then go real close to the window, but it's exactly not touching as you can see here. It does fit pretty well, I think. So it takes the air from here, from the window slit, then it blows it out inside, and on top would be the filter. I forgot one thing, I have to mount the bracket for the sensor. And these two holes will remain unused for now. This is how it looks like. And from the top with the sensor, that closeness was not part of the plan. I used that filter for at least few days and you can see inside there is a mosquito trapped. Anyway, so it should normally fit in. It's not loose, but it's not that tight also. I shouldn't have removed the phone. Let's start. There is definitely much more air. Blowing much harder. The problem is that most of the air is here, not here. But I think with time it should equalize somehow. The next thing I have to do is to wire up the sensor, make sure that it works. I'm not sure if I should make the fan spin depending the pollution inside of the room or also the criteria, which would be the time, because I don't want that thing during the night. What's next is to program that controller so it could communicate with the sensor. So that's normal. I haven't plugged that yet. Different particle size, humidity, NOx, temperature, and VOC. So everything is now printed. This is the bracket for the filter with the opening for the sensor. I still did reusing the old foam that we have on the old filter, which would seal that bracket for the sensor. This is a really expensive fan. I haven't ordered something that expensive for a fan. I bought it specifically because it has a high static pressure and also some rubber gasket over here. I made it so it perfectly made the surface on here. On top of that we'll sit that bulbous things that are there from the 250mm window vent to that 120mm fan, and it will be using the ambient air as opposed to this one that will measure inside of the bell before entering the filter.
a bit large overall, but I wanted to use a big filter. I could reduce that later on. The previous version was working, I'd say okay, but it was definitely too noisy. Look at that amount of mosquito in. I think I made a mosquito filter. This works well, but too noisy. Not the best soldering I've ever done, but that's good enough. 2 of them, because I have 2 addresses. 69 on the datasheet. They said that the I2C address is 069. Problem is that I can't change that, so both sensors were trying to communicate at that same address. Instead, what I'm going to have to do is to create 2 separate buses for those 2 sensors. This is the circuit I'm going to use. It will input the 5 volts and output the 12 volts for the fan. Ground, 12 volt, fan signal for the RPM, and the blue cable for the PWM, the signal that will modulate the speed. But I have to first make sure that this outputs a 12 volt. 22. A smaller fan, 92 millimeter. It works. Shouldn't spin because I turned it off. I'll turn it on. Ooh, this is 50%. It's taking a bit of time to get to there. 11.78. Let me turn that off before I chop my finger. That hell of a monster, but it works. The PWM works. I will have to make it cleaner, I think, something like that on the top. I hate this. I have to say that I made a mistake. I use this board. It's called the C3, and the problem is I thought I ordered the S3. The C3 has only 1 bus, the S3 has 2. I think I have to redo the whole wiring to use that full-size board, and this will ensure that I have the 2 buses. That should work. Put that in. But it's definitely not the cleanest way to mount this. Cables are a bit short for that. I have to make something work before making it clean, because there is no point in wasting time making it clean if it doesn't work, right? On the UI I have these shown over here. The first sensor and the second sensor. Just to move that fabric in front of that input sensor. This is the filter that will measure outside, and this is the sensor that will measure inside. It's still amazing that I have a fan like this running on a battery with a 2 sensor, and it's communicating with Wi-Fi to my home server. So I'll place it outside like this, and we'll see about the reading. Now this seems to be working fine outside with the battery. The filter. Power monitor, 3 amps. Online, with the fan off, I can turn it on to 50%. I can hear something. The difference where inside I have 14.2 or about that, and outside I have 27 something. I bought this. It's supposed to be the same sensor that I have, so I bought different size of foam. This one is a bit more dense. It's too tight now. What is that? So the system has been running for about 3 days, and I have to say that I'm not so happy with the result. Let me show you. And as you can see here, this was the level when I was sleeping. 1200. It's actually better than before. This is normally what I have. 4000. And as soon as I started it, the level was 4000. But when I started it for the night, it stayed at about 2000. So I ran it the whole night, and that day I got about those 2000 something. The problem was I didn't thought about it
So what I have tried is actually blowing fresh air from the window to inside, and now I actually did the opposite for this night, where I moved that filter and the fan is actually blowing air out. So the air is coming supposedly from any possible leak, mainly from the door, so it will bring not that bad air from the house and push it out from that window. Because as of today it has been running quite well, and it stays at about those 1,000 or so, which is not bad. So we have gone from 2,000 to about 1,000. 1,000 is not that bad. I had to increase the fan speed much higher than I would like to. It's been working pretty well with that 120mm fan. It's been going for about a week, but now I wanted to test few things. I got this, an anemometer. I will be using it to compare between different fans, because I'm not sure sometimes that if I increase the fan speed it actually goes quicker or it just gets noisier. So the vent is up there. This is what we got. 2.5. 2.5 at 100%. I can't even hear it. It's about 0.7. So I've been doing quite some extensive tests, but the last two I want to do is to test with this small fan and this one that is working fine with a 120mm, but this one is much cheaper. I made something for this. Instead of redoing the whole thing, I'm just making some adapter. That way I don't waste any more plastic. This has been working well with the 120mm. And you see, my goal is to equip that in my whole house. Using about 35 euro for a fan. I can't stand that, that's too much. So what I'll do now is I'll swap that with the 120. And for the final test, I can say that the filter has been working well, because I've just removed the filter for 10 minutes and I already have some allergies going on. But that new fan is installed and it's all white. Usually I found that the other fan is at 30% alright, like not too noisy. Let's try it at 100. 2.8. 1.4. That's so nasty. 0.9. So in the end, I'll ship back that Be Quiet fan. This could be as good as it gets. I'm not measuring much difference. I mean, for a computer, that might be worth it, like if you have a high-end computer. I used a regular PC fan, and from what I'm seeing now, I'm worried about the durability of that fan, because seeing the amount of dust that goes through, if I want to keep that model with the fan running, I might have to change the order and put the filter first. But I'm not sure the fan will like it a lot to pull the air through the filter. So what I did is that I combined a presence sensor in my room, which turns on the filter at full speed whenever I'm out of the room. And if I come in, then it will turn down to 30%. This way, I actually never hear it running at full speed. But it takes care of venting properly the room, because the dust is one issue that I have, but the second one is actually the CO2 level that I wanted to lower. The particle level is much lower inside than outside. I have seen about 50% reduction in the CO2 level in my bedroom, which is already great. Now if you couple the reduced amount of pollen, particle and CO2 level, that makes it worth it. What I might want to test next is to have it completely passive with no fan. The CO2 level won't drop,
because it's only decreasing if more fresh air is coming in the room, and the filter is not helping it. What it does with the filter is reducing the amount of PM, particle matters, in the room, and in my case, a lot less pollen in the room. And I can tell you that being in your house and feeling sick because of the pollen is one of the worst nightmares that I have. This is now solved. In the end, it is worth it for me. Would it be worth it for you? I will let you decide. If you are interested in the plan, I will include that in my Patreon link. Have a look at it.